rate laws. Okay, introduction to rate laws. And a rate law is a mathematical model that attempts to describe the effects of reactant concentration on the rate of a reaction. So if you just back up for a second, is that how much concentrations affect the rate of a reaction. And the thing is that every reaction is different. So mathematically we can look at it. Obviously it makes sense usually that the more reactant there is to undergo the chemical reaction, the more faster it's going to go. But we can do the math to figure it out. Okay, so once a certain amount of product is formed, they can combine to reform the reactants. So this is where I was talking about. You're going to get some reversibility no matter what. And because reactions are reversible, we want to avoid the added complication. This is kind of like when we talk about making solutions and we say the volume stays the same. We'll study the reactions soon after they're mixed, so we essentially can ignore the reverse reaction. But this is just the reality that I was talking about, it is that if you leave it long enough, it may be a very small amount, but ultimately once you kind of get to that endpoint, some of it's going to start to flip back, just because there's so many atoms that it's going to happen. So anyway, when we focus on the rate, we're mostly going to focus on the concentration of the reactants. It's good to explain it from the product side in the beginning with the oxygen and the nitrogen monoxide that we were just talking about, but for the most part we're going to focus on the reactants. Now, a rate law, again, is an expression that shows how the rate depends on the concentration of the reactant. So in other words, how much it's going to impact the speed of that reaction. So for example, this is the standard setup for a rate law. And here's what you've got. Lowercase k. Starting with chapter 13, we get about 4 different capital K's. This is lowercase k. All right, and we saw this with freezing point depression and boiling point elevation as well, but those were lowercase f for freezing point, lowercase b for boiling point. This is just k. So this is what's called a proportionality constant. We call it the rate constant. And n is what we refer to as the order of the reactant. Now, you cannot, it's going to be first order, second order, third order. It's really easy to get caught up in squared or cubed, but you have to determine it experimentally. Okay, it's usually a positive integer. It can also be 0 or a fraction. For the most part in this class, we're going to focus on first order and second order, but I got to put this in there because it can be 0 or a fraction. It also can be third, fourth, etc. We're going to mostly focus on first and second order. Okay. Now, the rate law must specify which reactant it's referring to, and it depends on what reactants or product it is defined in terms of. The value is going to depend on how the rate is defined, because you're going to see, as soon as you see some of these simple problems, you'll see how we use the numbers and we kind of plug them in to determine k and then to go back and figure it out. And there are a few types of rate laws. The first one is the differential rate law. This is exactly what we've been discussing. When we just say rate law, that's it. This shows how the rate depends on the concentration of the reactant. So in other words, as the reactants are used up, the rate usually slows down. Those are pretty common characteristics. Now, integrated rate law. This is where, for those of you that have had calculus, it's going to help. For those that have not, you're going to be fine. I'm going to show you the button to hit on your calculator. You're just not going to understand all the math or the proof, essentially, on how to get there. And this shows how concentration depends on time. And a specific type of differential rate law is always paired with an integrated rate law. So you're going to see a little bit later that I'm going to talk about the integrated rate law for first order, integrated rate law for second order reactions. And those are going to be something that you just have to memorize and know that it goes together. And we'll do lots of practice problems. Okay, I hope that helps, and see you in the next video.